G'day and welcome to the third video for the binomial distribution. This one I'll show you the difference between BinomialPDF and BinomialCDF, or I guess I'll explore that a little bit now. So going on from our previous trial, so I'm flipping the coin 4 times, and in the previous question it was what's the probability of obtaining 1 tail out of 4 flips. This time I want to explore what's the probability of obtaining at least 3 tails. So that means that out of 4 flips it could be 3 tails or it could be 4 tails. Okay, so again I write down all of these things. I know that it's the binomial distribution, so I write n equals 4, the probability equals a half of the success, I should say, and I know that my x value, the number of outcomes I want, is either 3 or 4, so I can write x as greater than or equal to 3. It does make a difference when it's greater than or equal to, or just greater than, so be careful in the discrete random variables. So now I'm going to write it down like this. Probability that x is greater than or equal to 3 means that the probability that x equals 3 plus the probability that x equals 4. And then I just go through and I put these two things into my binomial distribution formula. So 4c3, a half to the power of 3, and then a half to the power of 1, plus 4c4, a half to the power of 4, and a half to the power of 0. I'm not going to go through how to get all of these, I'll just kind of show you what they are. But I would assume that you know how to get 4c3 and 4c4, and you know how to do half to the power of 3, all those sorts of things. So I end up getting 4 times an eighth times a half plus 1 on 16, and I end up getting 0.3125, or if you wanted to, you could get that the fraction equivalent of that as well. I guess I assume that you can do that. There are a couple of other ways of working this out, and this is where I'll show you BinomialPDF and BinomialCDF. So other ways of working this out is I could have done the probability that x is greater than or equal to 3 is the same as 1 minus the probability that x equals less than 3. Okay, and this is when I was talking about in one of the first videos, the probability of a plus the probability of a complement is equal to 1. That's kind of what this is here. And x is less than 3 is x equals 0, x equals 1, and x equals 2. Just be careful to put your brackets around all of them like this, okay, so that these ones are subtracted in the end. Or you add them first and then subtract them all together. The other way that you can work this out is by using the CAS calculator. And you do need to know how to do it by hand, but obviously we won't give you large numbers when you're doing it by hand, we'll give you rather small numbers. But using the CAS you can work out any numbers really. So what I do is, again, I go to menu 5 and I go to the distributions, and I might show you that on my calculator. So menu 5, now I go down and I have a look, BinomialPDF and BinomialCDF. CDF is, I don't exactly know what it means, but I believe it means cumulative distributions. So that means that I'm actually adding up lots of outcomes together, whereas in the PDF that's just one probability worked out. So I push BinomialCDF, and I'm going to say for number of trials, the probability of success is always the same, or for us it's always the same in this question. And then it says lower bound and upper bound. Now I said at least 3 tails. That means that my lower bound will be 3, and my upper bound will be my maximum, which is 4. And I can push OK, and it gives me the answer that I had before, 0.3125. Okay, so I'll go back to my notes. 0.3125, that's exactly what I had up here, so it's the same answer. So when we're doing BinomialCDF, we can put our lower bound in and our upper bound in and get the answer. But we just need to note that BinomialPDF is different from BinomialCDF. PDF is just one outcome, CDF adds up multiple different outcomes. Okay, so they're both quite useful, just depends on the question that you're actually after. Okay. So hopefully that's explained the difference between BinomialPDF and CDF. In the next video I'll look at measures of spread, so mean, median, mode, and all those sorts of things. Okay, so thanks for watching, and make sure you watch the next one.